So today we'll be talking about how a real Google project is migrating a very large code base from AngularJS to Angular. We'll tell you about some of the strategies decisions we've made along the way and how we think about migration. We'll also cover real code that shares the technical details of how we're implementing these strategies. And we'll also talk about some of the lessons we've learned along the way. So I'm Jen Bourey. I'm the TL for client infrastructure on Google Cloud.
I'm Connie. I'm the TL for UI components.
So our product is the unified web console for the Google Cloud platform. And that includes things like dashboards and overviews, screens for interacting with and configuring cloud resources, and also some more complex and interactive UIs, things like logging and monitoring and code editing. Our project is currently using AngularJS. So as of the beginning of the year, we are on AngularJS 1.4. We're on 1.5 now. We have historically also used Clojure JavaScript, which is an annotation-based type-checking library. We also use Clojure GSS, which is a CSS library. And we have a set of pre-material UI components. Our project is also huge. We currently have over 700,000 lines of source code, excluding comments and whitespace, and another 700,000 lines of unit tests. So this is all content that would need to be rewritten for us to move to Angular. We also have hundreds of reusable components and services. And in addition to all of that code size, we have a lot of organizational complexity. So we work with dozens of contributing teams across multiple offices and time zones. And we also release twice a week. So we have to keep things completely working at all times. And then on top of all of that, we're still growing, and quite quickly. So in addition to the obvious challenge of migrating a very large code base, we also need to support launch velocity and developer velocity. Nobody's going to be very happy if we tell them that we just can't ship any cloud features for months and months while we rewrite our whole code base. In addition to that, of course, our developers don't really want to have to simultaneously maintain all of their new features in both Angular and AngularJS while we do this migration. And since we have a lot of shared services, that also puts us at risk for having teams blocked on each other as we have a lot of interdependencies. So how are we actually going to approach this migration? Our solution was to break up our UI into multiple independent migrations so that people could migrate in parallel on their own timelines. So starting with our AngularJS app, we have the portion of our page that corresponds to the ng view. So that's the part that changes as you navigate across paths. And then outside of that, we have a number of more static UI widgets. So things like login and logout, navigation, preferences, all that sort of thing. We knew that we wanted to allow features to migrate on their own. And we also wanted to give them control over how much they migrated at a time. So we settled on a page-by-page strategy, since that would allow teams to just migrate a single page at a time if they wanted, or migrate a whole set of pages and launch those. In addition to migrating on page by page, we also wanted to be able to migrate those UI shell widgets in parallel. So different sections of our UI shell can be migrated separately, and that can happen at the same time as our product page migration. One benefit to this approach is that as our UI shell is migrated, even pages that are still on AngularJS benefit from improved load times because more of our core page is moving to Angular. As we move on, the base page stays AngularJS until the very end, and then our last step is to clean up the core services and remove all of our bootstrapping, and at that point, we can just delete AngularJS.
Okay, so let's see how this is reflected in our code structure. So here is our pre-migration code structure. The most important thing to note here is the distinction that we call core versus product. So core is the horizontal stacks that you see here that are all interdependent and build on top of each other. Whereas our product UIs are largely vertical slices that are independent from each other and that write their own business logic. So for our migration, we want to do this in stages, starting from the bottom of this diagram and moving up. So the first stage is interop, and this is just getting an Angular app working alongside an AngularJS app. And the key pieces of this are what you would think with Bootstrap and routing. After that, we can do what we call our core migration, which is to migrate our core services or use ng upgrade, and to migrate our UI library. And we'll talk about each of these pieces separately. After that, you have the stage set for product migration. So each product will be able to migrate independently as much as possible, and we want this to be flexible and decoupled if we can. Part of that also means that as products migrate, they can clean up right away. So the first stage of cleanup, which is the next phase, is products deleting as they go. So once you're fully launched in Angular, you can go ahead and delete your AngularJS code. At the same time, as part of the core cleanup, we want to fully migrate all of our core services so that we have a clean separation between AngularJS and Angular. Once we have that and all of the product dependencies on core are gone, that's when we can delete all of core for AngularJS. And of course, the last thing to go is our base page Bootstrap, which will be there in AngularJS throughout the entire migration. But once everything is gone, we'll be fully an Angular app.
OK, so we've laid out this great strategy. But how are we actually going to accomplish this? Well, the first step is bootstrapping. So we need to just get Angular and AngularJS running side by side on the same page. So originally, we were using upgrade module. But in conversations with the Angular core team, they actually gave us another option called ng upgrade lite. You might have heard of this, but essentially, this allows you to separate out AngularJS digest cycles and Angular change detection into two separate zones. And for us, this was really important because we care a lot about performance. And this is how we got to have really great performance with our setup. This was also a very good match for us because we're not making super heavy use of ng upgrade. So we're essentially upgrading services and then downgrading a limited number of components. So this is working great at this point. And one of the other benefits of ng upgrade lite is it's actually much easier to bootstrap. So we have our AngularJS application, one application module, and then we have an Angular application module. We use downgrade module to downgrade that root Angular application module, and then we add that to the module dependency array and feed that to Bootstrap for AngularJS. And that's it. We actually have Angular and AngularJS running side by side in our application at this point. But of course, we need to figure out how to actually include this in the page, right? So it's not enough to just have them running side by side. We need an Angular component to actually show up inside of our AngularJS app. And this is where downgrade component comes in. So as an example, we want to be able to include the Angular router outlet in the page. So this is a just very simple component. It just wraps router outlet, and then we define a new ng module for this component. And the important piece here is that this new component gets added to the entry components array. After that, we can just call downgrade component on our Angular component. That outputs an AngularJS directive. And then we can just include that AngularJS directive directly in our AngularJS base page. There was nothing magical about the router root in this last example. So this can be extended to other UI widgets. So if we want to be able to rewrite, say, our login button in Angular, we can use the same approach. OK, so up until now, I've just sort of showed this ngview router outlet thing. How do we actually get routing working in Angular and AngularJS at the same time? So this was actually very important for us. Some of the initial conversations we had revolved around things like, well, maybe we can have like a page wrapper that downgrades a whole page, except we actually are really excited about the new Angular router. It offers things like can activate guards and child router outlets, and we want to be able to make use of all that. So we actually want to use the Angular router directly. So to do this, we're actually running both routers at the same time. So sort of similar to how we're bootstrapping both applications, we set up both routers. And we actually have both routers seeing and handling every single path in our application, regardless of which system kind of owns that path. But we make sure that only one of the systems gets to actually render content. This is also useful because it means that both routers always have a state, and they can always see the current path. So this can help out with some of those ng upgraded services as well. So in this view, we have an ng view and a router outlet side by side. And then depending on which framework we think is active, we actually show and hide these. So when we think we're showing an AngularJS page, we hide the router outlet, and AngularJS takes over and renders content, and then vice versa for Angular. We need a little bit of glue code to make this work. So there's a location synchronizer that allows Angular to actually know when AngularJS has updated the route. There's one of these in core already. It needs a little bit of tweaking to work with ng upgrade Lite. So if you're interested in following that as we get that back into the core code base, that's the GitHub issue to watch. To ensure mutual exclusivity, we have a small array of path prefixes and regexes, and then we just have a little function that for any given path can return whether the path is registered to Angular or AngularJS. And then we use that in both of the routers. So on the AngularJS side, we use an otherwise block to map that to a single controller. And then the controller checks whether this is an AngularJS or Angular path. And if it's Angular, it just doesn't render any content at all. And if it's AngularJS, it renders a 404 page because the system believes that this path is supposed to be controlled by AngularJS, but we couldn't find a route mapping for it. On the Angular side, we have a little more powerful APIs. So we can use the matcher to be able to map this to a function. So this configuration here says, after we go through all of the main registrations, if it matches an AngularJS registration, just render this component that has no content. And then if it falls all the way through to the bottom to that wildcard route, then we render the Angular version of the 404 page. So at the end of all this, here's what we end up with. So our request comes in, it's handled by both the AngularJS and Angular routers, and then from there it branches out to either render content, render no content, or render a 404 experience. I'd mentioned before that we're not using ng upgrade very heavily, and I wanted to talk about a couple of the reasons why. So just as an aside, we weren't really planning to upgrade components to begin with. We're using a new UI library, so we didn't really think that it would be a great user experience to mix Angular and AngularJS components in the same page because some of them are material and some of them aren't. But there's some technical limitations as well. So if you have complex AngularJS components that use the $compile service, those aren't going to work with upgrade. So we were mostly focused on services. And as we started to write code, we found that sometimes writing code with upgraded services sort of force AngularJS patterns into Angular. And so at this point, we're avoiding using ng upgrade with a lot of our common services, but we're focusing on using it to decouple migrations. So this has been an absolute lifesaver for us, and it is working really well for this purpose. So imagine that feature A depends on a common service from feature B, and the feature B team hasn't started their migration yet. This allows them to not be blocked, and the first product team can move ahead. Here's an example at the top of some code that's using an ng upgraded service from AngularJS. This is using the $resource service. So we have a DAO, we call get, and then we have to call $promise, and then we get this whole promise chain. And this isn't really actually what we expected our Angular code to look like. Down at the bottom, that's code that's using a native Angular service. It uses observables. We can use observable operators. And this is kind of a little more where we want to get to. So as a result of that, we're not using we're not using ng upgrade for all of our common services. There are also some potential hurdles if your services do things like access the root scope or broadcast events that can make ng upgrade a little bit tricky. And we also found some test friction as well. So if you use an ng upgraded service, you need to add that to the super providers list. And if you forget to do that, the error can sometimes be a little bit inscrutable.
All right, so let's take a look at a last piece of interrupt that can be unexpectedly complex. So this is styling, also called Connie complains about CSS. So as part of our migration, we decided to change design languages. So we went from the classic Google Kennedy design language, think Gmail, to material design in Angular. And not all projects will be doing something like this, but it definitely exaggerated the problems that we ran into with CSS. So we have a lot to talk about. So the challenges we came here with are scoping CSS to regions of the page and layering CSS from multiple sources. So let's talk about each of those. So with scoping CSS, the problem is that CSS is very global, but we really want to be able to decouple different parts of the page in their migration. So any particular part of the page could be in either framework, and it could be in either design language. So the tools we use to address this are pretty standard: container classes, naming conventions, Angular view encapsulation, and we'll talk about each of this in the context of a diagram. So here's the ideal of what we want in our UI. All of the UI shell, including the top bar and the left nav, is going to be in Material regardless of which framework it's in, AngularJS or Angular. Whereas the page itself, if it's in AngularJS, it's going to be in Kennedy, and if it's in Angular, it's going to be in Material. So the way we did this is by drawing all over our diagrams with boundaries. So on the boundary between AngularJS and Angular, and between Material and Kennedy, we have prefixed naming. So as a familiar example, AngularJS Material uses the MD prefix on all of their class names, whereas Angular Material uses mat as their prefix, and this is one of the reasons. In addition, for all of our Angular pieces, we further encapsulated them using either a class on some top-level container in the DOM, or we relied on Angular's view encapsulation for components. And this extra layer of encapsulation was for both stability and for layering. So let's talk about layering. Why do we need to layer? Well, it's because we have a million sources of CSS. So we've got our own Kennedy styles, our own Material styles. As I already mentioned, we're also using AngularJS Material and Angular Material. And for each of these sources, they're split into what I'm terming the background and the foreground styling. So the background is theming and reset and HTML defaults and things that apply pretty globally. Whereas the foreground comes with UI components and is also used to override other pieces of styling that you might not like. So the good news is that CSS comes with layering tools. Cascade order is within its name, and specificity is another tool you can use to override other pieces. But the problem is, with Angular's AOT compilation, you get unpredictable binary ordering of your CSS, especially for the foreground. You don't really know what order it's actually going to be in your header. So while we would like to have a nice, neat cascade order here, where you have the background elements first and the foreground elements after, and you place your own foreground above the external foreground so that you can override it, it doesn't really work that way, and it's not really that nice. So in reality, we do something a little bit more like this, where we rely on specificity and extra layers of encapsulation to make sure that our foreground comes after the material foreground, Angular material foreground, in terms of style ordering. Short disclaimer, this is actually a lot more complicated in reality, but that's a rant for another time. So we've got interop working. What do we do now? So we move on to our core migration. If you remember, we did our migration in various stages, the first one being interop and just getting things working side by side, but the next one being core migration. So this is migrating core services, migrating the UI library, and creating migration tooling. So we already talked about core services in terms of ng upgrade, so let's focus on the UI library. So what is the UI library? So going back to our old diagram, the UI library sits in between core and products, and so it's the piece in between that helps to glue them together. So let's unpack this a little bit into a scary-looking diagram that I will explain. So you've got product UI, which is built on its own business logic and has its own tests, and all of these pieces plug into UI components. Both those UI components and the things that plug into it are what we're calling our UI library. So the biggest part of it is our UI components. These are some visual examples of them. They are reusable components in our UI. They are Angular components, and they extend Angular material, which we are using heavily. They're mostly stateless, mostly content agnostic. Basically, they accept most things through projection. In addition to the UI components, our library is also composed of a bunch of plugins, things that you use to interact with components. And this can extend all the way from working with templates to working with the TypeScript to working with testing. All of these things, any number of these things can be applied. And it's all nice to have. It's icing on the cake. So why invest in this? Why have such a heavy UI library that is so extensive? Well, there's a lot of generic reasons to want this. There's a reason why Angular material exists. I would encourage looking at that and looking into how a UI library can help. But the thing we're focused on here is migration. And the biggest thing this gives us is that it reduces the time and effort of product migration. And one key factor in this is that the more extensive your UI library is, the easier it is to write migration tooling because your code gets more consistent and you can map things better from AngularJS to Angular. So let's talk about that migration tooling. Again, there's many types of tooling you can write. My first disclaimer is that you're probably not going to be able to tool away your entire migration. It's not just going to magically do it for you, but it will do parts of it. So we've explored almost all of these types of tooling, but the one I want to focus on here that's most relevant to the UI library is translating template syntax from AngularJS to Angular. So this is best shown by just a short example, but first, let me just go back to this diagram. Our template migration tooling is focused on this part of the interaction, where you have the product UI interacting through templates with UI components. And a transformation looks something like this. So this is an example using AngularJS material and Angular material, where we have a select component that maps one-to-one in both libraries. And the transformation you're making is both with the syntax of the template and with the actual component pieces and the subcomponents and everything that goes into it. And again, why invest in all of this tooling? Why continue to grow core at this point? The biggest thing is that migration burden can be passed from products to core. The bigger your core migration is, the smaller your product migrations are going to be. And the smaller the product migrations are, the less time they take, the more independent they can be. And it turns out product teams like this. And so having a good, strong UI library and tooling is a big way to sell and motivate product migration. All right, so speaking of product migration, what's next? Well, what's next is we're running out of time in this talk. But what it really is we have kind of caught up to our story up to this point. So where we are at is we have interop functional. Our UI is functioning fine side by side. And our core migration is largely complete. We're feature complete. We've started some experimental migration, and actually we're well into, we have a pilot launched, and we have teams looking at moving more and more of their code base. And there's a lot more to explore, right? There's a lot more product migration to do, and there's a lot more to learn, and we haven't even thought about cleanup yet. But there's also a lot that we've already learned, so let's focus on that. All right, what went well? Well, better technologies, for one. Angular really is great. All of the talks you've heard about unicorns and rainbows and happiness are true. TypeScript in particular is really great and good to work with, and all of this has contributed to a lot of great developer productivity improvements. So that, I think, would be the biggest thing. The other thing is we've had a great collaboration with the Angular core team to work through things. In a lot of ways, we were their guinea pigs, and they were very kind to us. And we have really gotten their help on a lot of things to get interop working. Some of the things we wish we had known going in. So we glossed over this piece because it wasn't really super relevant, but we had a lot of trouble integrating with our internal build systems. And this is possibly also going to show up if you have your own internal build systems. Another thing we wish we had known is also the trade-offs that come with ng upgrade. As Jen mentioned, we did go in initially thinking we were going to use it pretty heavily, and then we ended up pulling back from that. And another more organizational thing is that when you're doing a large migration of your code base anyway, there is a temptation to say, well, why don't we just lump this other migration in with it? And that times 25, and suddenly you have a super unmanageable and crazy migration that's really hard to manage. So that's something to watch out for. And then lastly, we did run into a lot of framework level blockers as a large project who's kind of working with the Angular core team very closely for some of the first times. But hopefully we've ironed out a lot of this for you, and it'll be a lot easier the second time around. So as some final thoughts, there will be trade-offs and decisions to be made during migration. Having clear goals and priorities will help, but there are a lot of people with a lot of different priorities. There will still be some unknown hurdles. Hopefully we have ironed out some of them for you. But there will also be continual and measurable progress. So with that, good luck, and thanks.
Thank you, Connie.